Boy, do I have a reaction that I want to show you. The reaction between hydrogen and oxygen. And I've got the two already, right here in this balloon. Hydrogen and oxygen gas mixed together. Now, you might say, where's the reaction? Well, unfortunately, at room temperature, those two react very, very, very slowly. But if we provide enough energy, and that's what activation energy is all about, you'll see a much more vigorous reaction. Now, I'm going to warn you, and I'm going to put these on. This is potentially very loud. So I'm going to advise everyone to cover their ears, and I'm going to use these. Okay, we ready? Hydrogen and oxygen. Okay. Wow. But why wasn't that reaction happening between those two at room temperature? What's special about the little bit of that little tiny bit of energy I added in? It released all that extra energy. That's an exothermic reaction, but how do we explain that? Well, I have a little device here that's going to help. You recognize this? And that's right. It's a racquetball. I got it on sale. It was half off. Oh, sorry. Yeah. Okay. Actually, this is less than half of a racquetball. Here's a full racquetball, and if you look carefully at a racquetball, this is to help you make one if you want to do this. I think you will want to do it. There's a little pale seam you can see right there along the equator. And if you take a razor and cut into that seam there, utility knife works too. Boy, that's a tough one here. Okay. There we go. Once you get started on that, it tends to rip open pretty much right along that equator. Okay? Now, if it were really a half a racquetball like this one, it wouldn't work. The demonstration I'm going to show you, this doesn't stay flexed enough. So I have to trim it down. And you trim it down with a pair of scissors, and you cut a little bit at a time off. You don't want to cut too much off. So you cut a little bit, and you try it. And what I mean by try it is you turn it inside out, and you try pushing it back. It's got to be real easy to push back. That's too hard. So I trim off some more, and do it again. Trim off a little piece. But if you go too far, you try to rush it, and you take too much off, I'll show you what that looks like. This one here, I've taken too much off of, just barely. But see how it won't stay flexed like that? But this one's just right. I've trimmed off just the right amount that it stays flexed, but doesn't take much to invert. Okay? So this is what I'm going to use to demonstrate this. I call this Racquetball Kinetics. Okay? So this is an example of low potential energy. It's the relaxed state. But this is where we started with the hydrogen and oxygen. Potential energy stored in those bonds. So this represents the hydrogen and oxygen, and this, when I drop it, represents the hydrogen and oxygen molecules colliding, but at low energy, room temperature. Not much going on there. So what do? We added energy. How do I show that here? Lift it from higher up. Okay? Now, not only does it have to have the right energy, it also has to have the right orientation. It fell a little bit sideways and didn't go that time. But, oh, someone can get that? I'll get it. If you drop it with the right energy, sufficient energy, and the right orientation, we have this interesting situation. Oh. There we go. That racquetball left the collision with more energy than it did when it came into it, more kinetic energy. Well, I know that because it went to a greater height than from where I dropped it. So, well, that one was bad orientation. There we go. That was a good one. Okay? That's a perfect model for an exothermic reaction because the stored potential energy of the hydrogen and oxygen gets converted into the much greater kinetic energy of the product, which was H2O in this case. So, here's the hydrogen and oxygen, stored potential energy, but you can't tap that potential energy if you have insufficient energy. With enough energy and the right orientation, you can tap that potential energy and convert it into kinetic. And that's an exothermic reaction. Now, one final thing you can do with this, I'd be remiss if I didn't show you this. I've been dropping it this way all the while and making the racquetball part go up in the air. But if instead I turn it this way, if I drop it just like this, nothing much happens. A lot of noise, but I don't get much in the way of height of the racquetball. But if instead I drop it this way and put a ping pong ball in the middle, yeah? Now as it drops, the energy gets transferred into a much, much lighter object. Same amount of kinetic energy into less mass should mean a lot more velocity. So let's check this out. Whoa! That had quite a bit of velocity as it left. So there it is, racquetball kinetics. Thank you.